Good morning, good afternoon, good evening. It's a pleasure to be with you today and looking forward to sharing with you some of the observations, thoughts, and plans that Cambium Networks has in exercising fixed 5G. We'll take kind of a broad panorama of the landscape and set the stage for the investments that Cambium Networks is making and bridge those investments to 3GPP's 5G initiatives around fixed wireless broadband. I would consider this presentation a survey, if you will, high level. And at the end of the session, I'll share with you a schedule of forthcoming thought leadership presentations that will expand on specific ideas that are presented in today's session. We do have two polls that are embedded in the presentation today, and I'd encourage your active participation in those polls. It'll help us form input and content to future discussions. I'd also encourage you to take advantage of the opportunity to post questions in the question panel, but I also suspect that we'll have some time at the end of today's session for some live interaction with myself and Anthony Jamin, who is leading our 5G development out of our Ashburton, England Development Center. So with that said, let's go ahead and get started. And I want to start with a view on the renaissance that's taking place in the 5G space. And there truly is a renaissance underway, in part driven by COVID, certainly, and I guess that's an unfortunate initiator of that renaissance, but also I think an embracing of fixed wireless broadband as a legitimate alternative to wireline and fiber solutions. There are a couple of key drivers behind that renaissance from a use case standpoint. And again, courtesy of our friend COVID, the work, learn, and entertain from home is certainly driving utilization of fixed wireless broadband. Millions of connections around the world in place, and the number of subscriptions is accelerating as individuals need improved and more consistent broadband at home. And the connections or circuits that were in place, we've seen a significant update in the capacity of those networks. If you look at any third-party surveys, what's in part driving the demand on those networks is over-the-top media access. Whether it's Amazon Prime or Netflix or other alternatives, the demand that media places on the networks is significant, and the technology is stepping up to support it. And we've also seen an acceleration in industrial automation. The proverbial industrial Internet of Things is accelerating as companies look to automate remote monitoring and management of their systems, in part to reduce operating expenses, improve their operational efficiency, and in an effort to minimize the human resource exposure to the environment. These are just three examples of what's driving it, and I'm sure there are many more, but fundamentally an ever-increasing demand for fixed wireless broadband access. In parallel with that activity is really something unusual in the industry, and that is a phenomenal increase, either immediate or in the immediate horizon, of spectrum. I think folks on this call are certainly following the advancement of 6 gigahertz. The FCC initiated that effort by opening up 1.2 gigahertz of spectrum, and that's going through the rules making process, and I would expect access to start to emerge in the 2021 timeframe. But you also have ETSI advancing it through their 303/687 effort. You see Brazil having taken action, and South Korea already making that spectrum available. And I, again, suspect that if we took a survey around the world, we'd see many other countries moving forward with 6 gigahertz, which is significant and will buoy the fixed wireless broadband industry. In the US, there is an interesting experiment that is really transitioning from experimentation to active utilization, the Citizens Broadband Radio Service, which opened up 150 megahertz of spectrum with a novel spectrum sharing approach. Incidentally, on Tuesday of this week, the FCC concluded the auction the leased portion of that spectrum. And initial results indicated $4.6 billion in investment from service providers in that spectrum across 271 participating agencies. I think what's important on CBRS, and this will be a future webinar from Cambium, is the adoption of shared access spectrum services and solutions beyond that 3 gig band. And you see it in the FCC's efforts with 6 gigahertz in automatic channel assignments. On a worldwide basis, 60 gigahertz is advancing. You'll see Cambium Networks introducing product in the 60 gigahertz space yet this year. And certainly the 5G effort on a worldwide basis between 24 and 29 gigahertz is progressing, with some portions of that being licensed and some portions of that being unlicensed or lightly licensed. But in aggregate, last couple of years and the couple of years to come, we'll see a significant expansion of spectrum available to service providers to deploy fixed wireless access, which is supporting this renaissance. The standards bodies are keeping abreast of this activity as well. On the Wi-Fi front, 802.11ax or Wi-Fi 6 is very active and progressing, principally as a Wi-Fi access solution, but other companies like Cambium Networks are using that as a foundation of fixed wireless solutions for outdoor deployment. On the 60 gigahertz front, and we'll drill into this in a bit more detail later in the presentation, the advancement of 802.11ay and the substantial impact it has on the total cost of ownership for 60 gig solutions by enabling more comprehensive deployment applications and solutions. And kind of the cornerstone of today's discussion, 3GPP's advancement of 5G NR from release 15 and forward. So you see demand, you see spectrum becoming available, and you see standards advancing it. And behind all of that is, of course, technology. And these are just 3 reference points. There's a great deal taking place both on hardware and firmware, but massive multi-user MIMO is a critical enabling component for spectral efficiency, the density of these networks. Cambium initially introducing a massive mmWave in a 14 by 14 configuration in late 2016 with our CNWave technology, but you see that advancing quite significantly in mmWave implementations, and Anthony will speak to that further. In conjunction with that, particularly in the higher RF bands and the necessity of easing alignment to minimize installation costs and time of installation, the use of smart antennas has progressed significantly. And while systems on a chip aren't new by any stretch of the imagination, what you see is chip vendors like Qualcomm really keeping abreast with the advancement of spectrum and the advancement of technologies and bringing forward SoCs that enable cost-effective solution development. And I want to rotate back for a moment to 3GPP. While many of us in this industry, Cambium being a notable example for decades, what 3GPP did with 5G is really legitimize fixed wireless access by incorporating it overtly in the standard. And in the case of 5G, the initial deployments of 5G were fixed. And you still see today advancement of fixed deployment of 5G, and that is accelerating, and again, part and parcel to today's conversation. So why does 3GPP 5G matter for fixed access? Well, first, release 15 provides a fairly significant foundation for fixed access, and we're going to touch on what elements of release 15 are notable. And again, the validation from an industry standpoint for fixed access. No matter how you cut it, higher data rates drive the industry, and that's a market-driven exercise. But the need to support ever higher data rates with spectral efficiency is critical, and 3GPP took that to heart, and you see multiple attributes or capabilities within the release schedule to support those higher data rates. One of the negatives with respect to LTE or 4G was the inherent latency within that network, and certainly viable for browsing, certainly viable for email. Not ideal for sustained use in a fixed environment. And 5G addresses that lower latency with significant improvements in the architecture and performance. The network, 5G networks now also support denser networks, denser number of devices per eNode B or remote radio head, however you want to measure it. The density of client nodes that can be deployed, or CPEs that can be deployed within that network, is significantly increased. In part, that's in direct response to the industrial Internet of Things and the massive machine-to-machine communication networks that are anticipated and accelerating. But it does drive a more economically efficient architecture and total cost of ownership, which is supportive. Again, throw a couple rocks at LTE. LTE was predominantly a downlink-centric architecture, and those of us that are in this space of fixed wireless access recognize that while we're certainly not a symmetric environment, there's definitely a move towards a more symmetric architecture, a more symmetric demand profile. Just as a reference point, WISPA, the Wireless Internet Service Provider Association out of the US, recently completed a survey, and they were, one of the questions and results highlight this fact that upload traffic pre to post COVID was up 70%, while download traffic was up only 43%. I use only there with a bit of a grin, but so significant in and of itself, but you see a significant lift in upload traffic. And I think that's a reflection of the work from home, learn from home environment, where there's a more interactive engagement with the internet and the back office applications, and the need for more symmetric services from the solutions that are being brought forward. The 5G standard also includes very specific facilities for vertical market applications. And I'll call those out just real quick. The three high level is the enhanced mobile broadband, and that's really just lifting 4G to today's expectations and standards, a continuation of what's there. But beyond that, you also saw the inclusion of ultra-reliable, low-latency communications, and this was architected specifically for what would be characterized as mission-critical applications. So think of, in the utility and rail and oil and gas space, supervisory control and data acquisition. When you think of autonomous vehicle operation and platooning, where continuity of service and reliability of that service was critical for success and utilization. And then, as I mentioned, the massive machine type communication to support what is expected to be, and we're starting to see the green shoots of it, explosive growth in autonomous devices connecting to the network to support the Internet of Things. So I'm going to pause here, and we're going to put our first poll into play before we transition over to Anthony as he dives into each of the releases. Let me go ahead and launch this poll, and we'll just give you guys a few moments, if you don't mind, responding to it, and it'll help Anthony modulate his presentation of the next couple of slides. So the question was, at a high level, how familiar are you with 3GPP's 5G support of fixed wireless? And looks like we're settling on about 40% familiar, 50% somewhat familiar, and 10% not familiar at all, plus or minus there as the results come in. About 57% of you voted 60%. All right. Thank you guys for your interaction there. All right, let's go ahead and progress. Anthony, why don't you walk us through the next couple of slides, and I'll advance at your direction.
Thank you, Scott. So in next section, as Scott said, we would like to dive a bit more into the content on release 15, 16, and 17 of 3GPP, and specifically why we at Cambium get excited about those releases on what's coming. So starting with release 15, one key change compared to what we have in previous releases, native support for mmWave. I think that's a very important addition to the standards, as lots of 5G, obviously 5G and our deployment will be on similar frequency what we have been in 4G on up to typically 6 GHz, but there's also other part which is referred to as the frequency range 2 in the standard, and that's opening up support for mmWave. So there's a number which of feature or functionality which are required to support mmWave as opposed to the sub-6 gig. One of them is the acquisition. We for higher frequency we need to be able to acquire a subscriber. We need the beamforming, and that's what has been introduced in the standards in a way which allow to optimize the link budget. That's I think very key part on the standards. Another thing which has been the standard have been designed for is be optimized to support what the technology is capable at higher frequency. One of the limitation we see in when we go up in frequency is phase noise. So to cope with that, I think the standard have extended from LTE having a fixed subcarrier with DM subcarrier spacing of 15 kHz to having a variable a number of options of subcarrier boundaries up to 240 kHz, and that's helped a lot in mitigating the phase noise. So all very good background check on the interface which are required for mmWave, and makes the standards very viable for those frequency band. Clearly, as across been mentioned, wide channel size is important to support the higher throughput. So there's a number of features supporting viable channel size, and as well as channel aggregation. So we can support in the standard up to 800 megahertz of spectrum, which is very wide, really, for compared to what we have in LTE and multiple of 20 meg. Specifically for fixed wave access, I think a big difference between the standard and it has implication at multiple levels, but a very flexible frame structure. So that's again a change at the physical layer, but as an implication of a whole system. So Scott already mentioned one of them, which is allow more symmetric traffic, and the standard allow far more flexibility than the previous, like a LTE, and that could be almost full downlink up to asymmetric, or the other way, almost full uplink. There's a lot of flexibility at that level, and a lot of option to vary that demand dynamically based on the traffic wanted. Other function of that flexible frame structure is also the always-on signal, which for various reasons are minimized on the standard. So the frequency on the VT of beacon and always-on signal sent by a base station have been minimized in the standard, and there's several reasons for that. One of them is clearly a power consumption, but there are also others in terms of which is very important in terms of interaction with other system in a band. Not using a channel if you don't need to. We touched that on one of the following release as well. So all that flexible frame structure make a standard at the air interface level very well suited for the need of fixed wireless access. One feature which is quite important as well on fixed wireless access is uplink OFDMA. So that makes the CPE on the transmit side of the CPE quite efficient, and it's also part of the infrastructure which allow to do because we can, in one of the table at a given time, we can split the channel between several users. That means we have more opportunity to send acknowledgement on the uplink and keep the latency low. That's a good addition, and also the in terms of optimizing the cost of the CPE on the transmit side, that's a very positive impact. So that was for release 15. So we picked up only a few key points for fixed access. Obviously, there's a lot more in the standard. But moving on to release 16, which is being worked on at the moment, there is a number of attributes which I think we picked out specifically for their interest or how exciting they are for fixed wireless access. So the first one I think is very relevant to this presentation is unlicensed spectrum support. So by introducing the support from unlicensed spectrum is a very significant deviation from what 3GPP has done before. What that means on the implication of that is that we give access to the 5G NF technology to on all its benefits to users which do not have access to licensed spectrum. So a very significant move, and I think that will be a major shift in adoption of the 5G technology on the 3GPP in general. And I think that will be a key contributor to the convergence of fixed wireless access toward the 5G NR standard. Related to that, and closely related is allowing the coexistence with a non-3GPP system. So again, on that again, optimizing the access to spectrum. Similar to what is happening today with CBRS, there are a number of bands which are shared access. So allowing the standard to support other standards in the band mean coexistent, and therefore giving access to more spectrum, which is really the scarce resource in fixed wireless access. So very, very positive move as part of release 16. Clearly, one of the key parts of the key goal of 3GPP from release 15 on was supporting, as Scott mentioned, ultra reliable low latency, and release 16 introduced a number of enhancements around on that area. That will enable again a number of applications which will be mission critical applications. So yet again, that's another reason why we see the 5G NF standard becoming more ubiquitous. It builds on a number of technology which were used or different standards were used for different applications. It's kind of bring all the support required for those applications into the same standard. It's also extending that. The other part of it is support for industrial IoT. Again, having an infrastructure in place for fixed wireless access, another one for IoT, has been costly and worked well in the past, but as technology evolve and we integrate that all of our standards, that will mean that a network already deployed can now doesn't have to be dedicated to a particular application, but is able to support a number of different applications on a given infrastructure. So that's for release 16. So if you can go to next slide, Scott, please. Now we're moving toward what's the content of release 17. So that's far less defined. There's at this stage it's early days for the content of release 17, but so less detail into what's at what the standard we cover. But again, we picked up a handful of area where we believe there's quite interesting work being done. So the first one is supporting the 50 or the 60 gig bandwidth on the standard. So while in theory the standard as it stands doesn't specify any frequency band, certainly is agnostic in that they're up to up to 52 meg. The standard body decided to stop at 52 just to avoid that 60 gigahertz band. But as part of release 17, I beg your pardon, as part of release 17, the standard will look at supporting 60 gig band as well. So that will bring over a standard which can come on the interface. We could be used for anything from the 6 gig up to all the millimeter wave from the currently 26, typically 26, 28 band, 39 as well, especially particularly in the US, as well as 60 gig on the same air interface. So again, convergence of different technology today on different standards, and bringing all that into the same system, if you like. Dynamic spectrum sharing, again, more of what was already added in release 16. So again, very valuable there in terms of making use of all the spectrum available in the different application, different circumstances. Low complexity devices, I think, as the standard grows and is able to do everything for everybody, there is, I think, the concern that the technology and chipset becomes a bit too complicated or too expensive. So there's an initiative as part of the release 17 where we have a cost optimized CPE, which detail is still to be defined, but I understand we'll be having a number of capability of a device on the CPE on the customer premise equipment, which will be advertised by the device, and the base station could know what is supported and what is not. So that will allow reducing cost reduction of the devices on the CPE, which is obviously very important for large volume deployment. Two other points worth noting is one of them is integrated access and backhaul enhancement. So that IAB has already part of the standard, but more enhancement coming down the line. What that could allow is, in effect, providing the spectrum is available, is to have a lower cost, faster deployments of all wireless network, where you could have a number of tower covering an area. You wouldn't need to have to bring fiber or cable to each of the access point towers. Each of the tower could be connected with each other with an inbound integrated access and backhaul. So that has the potential to deploy, allow you to deploy as a user to deploy a network without requiring anything else. That's just wireless spectrum. There could be a whole network, or it could be an extension of a network where one a point of presence on a connection to a tower could then be extended to a number of tower in the area. And finally, coverage enhancement. So as there's more and more user using the standard on wireless, there are a number of options being looked at on how we could increase the coverage on each cell and provide effectively a more cost-effective network for fixed wireless access. Scott, I think that's what I had on the slide. I think the next one is back to you.
Yep, it is. So let me touch on a regular question Cambium receives, which is what is NRU and what are you doing about it? So I want to start with what is NR. Let's start with new radio, and it's often used synonymously with 5G, which is understandable but not quite correct. NR is really isolated to the radio access technology piece of 5G, and specifically, or more specifically, the 5G air interface. And there are, a vast array of enhancements or elements, attributes that define new radio. Two examples relevant to fixed wireless access is dynamic spectrum sharing, net new to the 3GPP effort. Likewise, with coordinated multi-point and synchronized sharing in terms of making most efficient use of the spectrum from an air interface standpoint. And NR is further extrapolated into the 3 applications that I referenced before. So bridging into, well, what is NRU then? Very simplistically, it's applying new radio, or NR, to the unlicensed spectrum. And it is defined in release 16, which was finalized in early July. So if you will, brand new, hot off the presses in terms of the exercise, and addresses the nuances of using unlicensed spectrum with or without an anchored licensed spectrum option. And examples include 5 gigahertz, certainly 6 gigahertz and 60 gigahertz. I mentioned anchored, and there's really 3 modes of operation, not unique to NRU, but certainly highly relevant to NRU. One is dual connectivity in conjunction with an LTE system. You may have heard about this in the context of 5G early on with the non-standalone definition, where an anchored licensed network was required. If it's a pure play 5G deployment, you can incorporate carrier aggregation, aggregating a licensed carrier with an unlicensed carrier, and certainly now supporting standalone in an unlicensed band. There are some nuances with unlicensed, by example, the bandwidths that are supported both on uplink and downlink, and we're not going to drill into the exhaustive distinction, but there are distinctions that need to be considered in developing a 5G fixed access solution intended to exercise unlicensed spectrum. On a more practical basis, this is the pivot point, in our opinion, for the use of 5G in private networks. One of the most challenging exercises of private networks, meaning those that are not tied directly to a traditional mobile operator, is access to spectrum. Spectrum in the license bands is very expensive and effectively restricted to those large mobile operators that can drive the economics across a broad population. The use of unlicensed spectrum or lightly licensed spectrum in the case of CBRS in the US will open up the use of 5G, particularly in fixed deployments, by private network operators. By example, the large industrials, oil and gas, rail, electric utility, municipal governments that want to make use of it, school districts that are looking for private networks, or maybe large industrial plants on the manufacturing side, agriculture, for example. So the inclusion or incorporation of unlicensed spectrum in 5G through NRU significantly broadens the application and the market opportunity for 5G, and certainly something that Cambium Networks is going to be taking advantage of. With that, Anthony, back to you, and for a brief introduction to Cambium Networks' first 5G development effort.
Thank you, Scott. So the first product that Cambium is working on and will be released next year is mmWave only point to multipoint system. So it will cover the 26 to 28 gigahertz band. So anything from N257, 258 on 261. So quite a wide frequency range, covering a lot of countries which have different requirements. What are the highlights of the product? So building on MMWave, on massive MMWave expertise, Cambium has acquired a few years on the 450 series. We are implementing a 8x8 mmWave system. We will be supporting both the 50 and 100 megahertz 5G LAC channel, as well as the legacy channel, which are multiple of 7 megahertz, so 56 on around 12 legacy channel size. So at the base station, we on on the 90-degree sector antenna, we are looking at supporting up to 3.2 gigabits per second in 112 megahertz channel. So very sizable capacity. Every sector can support up to 240 subscribers. So on a cell of 5+ kilometer radius, there's plenty of opportunity to add to that network and get a very good coverage. We'll be using on the CPU side, we have a number of good technology we have innovating with there, and we're looking at in particular at beamforming to add to make it easy to line the radio. That may not be part of the first release, but that's a technology we are working on at the moment on patenting and patent pending. So next slide, please. I think what our key differentiator of our project. So really we're optimizing our system for end-to-end for fixed wireless access. So we have a lot of benefit for several years, or 4 or 5 years now of mmWave, massive MIMO technology for CNWave on us, both as a physical layer on the beamforming, as well as the scheduling on how to optimize the throughput of the network over a large number of users. So based on the technology we have, on the experience we gain on CNWave, we taken all that which and bring it with addition on taking that into account from day one before we design the product, and optimizing the air interface and the 5G air interface on the setup of the 5G NR interface to get the best out of the MIMO. So for fixed wireless access, we will in particular reduce complexity by not supporting mobility. So that's a lower cost on making sure that all the functionality of the product is going toward improving the performance in a fixed wireless access. And for that, we'll optimize for high throughput, so high gain antennas both at the CPE on the base station. If you think of 5G and mobile phone, most application or most use case, because the mobile phone are very small, and the antenna also is quite small. At some distance already, the phone is mostly operated in low modulation and not getting all throughput. So it's a different use case for fixed wireless access. So all the system is designed really to take advantage of the propagation and the performance that at the top with modern high signal to noise ratio. At the same time, the 5G technology, we want to keep there's a lot of complexity on the hood, but we want to keep it as simple to deploy and operate as the common product we have today. And by that, I mean integrating as much of the GNOB as well as the core network. So we are looking at a standalone base station which integrate all that on is different from what a traditional provider of mobile equipment will be doing, where the system is traditionally split into 2 parts. So what it means is that we can have everything in one box, and if you install the BTS, it needs very little support outside of the BTS itself to be able to support a bridge to the CPE. And all that could be extended. At the minimum, the BTS could be standalone. Another point which is, I think, key for some of the WISP is layer 2 support. So that's another point which I could have added to my slide, where in LTE specified only layer 3 support. Actually, the standard in 5G allow you to support layer 2 directly. So that's mean that we can provide the layer 2 wireless bridge up to from the BTS to CPE, which is very similar to a number of the products we deploy today, and that's a preferred option for a number of our customers. Layer 2 could be added later. That's on the roadmap. But layer 2 is what we're get starting with. Another way to also make the system simpler is a SIM-free CPU operation. Again, mobile phone have identified otherwise by SIM. In the fixed wireless access, it may not make sense or be the preferred option. So we will have a CPU which supports a SIM operation like traditional mobile network, but we have also the operation to not rely on the SIM or not having a SIM fitted, on rely on the embedded certificate to authenticate the CPU. So again, trying to keep all the system as simple to operate for our customers as possible. So I did mention that we will be relying to be able to achieve a source frequency at mmWave. The range of 5+ kilometer will be requiring high gain antenna, and as our other product, we're not looking at self-install or customer install devices. We're looking at be optimized for professional installation where we have antenna line, and that's what gives us the possibility to have high gain antenna and operate at high throughput for the whole quite a large cell, the whole side of the cell. I did mention already the beam steering capability, which to his installation on address a number of impairment like wind and vibration of the mast. To give you an idea of the complexity or what we're dealing with is that we're typically looking at a sub 1 degree beam width for the CP. So as those frequency, those vibration on the movement on mast is becoming critical. So we're trying to make it again as easy to deploy mmWave system as it will be on a sub 6 gigahertz system. Another area we are differentiating that we are doing beam steering in azimuth only. Most of the product we see on the market today are designed for doing beam steering or analog beam forming in azimuth on elevation. From experience, we have already again on the CNWave on the 450 family. In fixed wireless access, from the base station point of view, almost all, because of distance to the CP, almost all CP appear to be, if you like, in horizon on a horizontal plane. The beam steering in elevation is not helping much. We have optimized our system so that we don't require the beam steering elevation, and we put all our effort, our technology on in the beam steering in azimuth. All the system is optimized for high throughput in clear sky condition. That's also a difference between what we see in massive MIMO system in sub-6 GHz, and we see in higher frequency in mmWave. So in mmWave, you're limited by the rain condition. One advantage of the massive MIMO in mmWave is that the system will automatically trade reach when you are challenged by the weather condition, where all base station power and transmit power will be, and receive power will be concentrating to reach further west subscriber when with heavy rain, but less than 1% of the time typically. But in the rest of the time, over 99% of the time, all the resources of the base station will be used to provide higher throughput on multiple beam to subscriber. So again, that's an advantage from massive MIMO, which come beyond what we already have on sub-6 gig systems.
All right, thank you for that, Anthony. So we highlighted that mmWave 60 gig is included in release 17 of the 3G PP 5G standard. Cambium Networks is not waiting on that specific standard to advance, but certainly will address it as it comes to market. We are advancing a 802.11ay based solution for our initial release of 60 gigahertz. And you may very well be familiar with 60 gigahertz and the AD standard. But as I mentioned, AY is a significant step up in capability and in driving down the total cost of ownership, which makes 60 gig a much more viable solution for fixed wireless access. A couple of the notable distinctions between the two standards is the CPE per sector, going from 8 to 15, which effectively amortizes the cost of the sector across almost 2x the number of CPEs. A significant uptick in capacity on a per sector basis as supported within the standard, a much broader channel width and channel support in terms of the number of channels supported. The transition to TDMA from CSMA is significant for fixed access. The contingency-based model is proven to be challenging for traditional fixed access. The synchronization allows for efficient channel reuse, and the addition of meshing, and in our case, alignment with Terragraph, really provides for agile network design and deployment that results in agility in that network design. We see a number of applications for 60 gig in a fixed model, and I would highlight these in specifically wireless to the home. So residential access, where we're able to provide fiber-like speeds much faster and at a lower cost of deployment to that home. Wireless to the building, you can think of this in a number of different manners, from multi-dwelling units, where you bring broadband to the rooftop and distribute within that building. You can also think of it in the context of campus area networking. Rooftop to rooftop, we see initial deployments of this already taking place as either the primary or the secondary distribution path for high capacity in dense urban environments. We see a natural touch point of 60 gig to cover the last 100 meters, 200 meters, 300 meters with fiber first network operators, where they are looking for a hybrid solution to accelerate their time to revenue, perhaps even contemplating it as a temporary solution while they wait for permits and the build out of fiber networks, but they can quickly reach a higher number of endpoints from their fiber point of presence using fixed wireless access, and 60 gig is ideal from a data rate standpoint. And certainly backhaul for small cell, outdoor Wi-Fi networks, micropop implementations, and the explosive use of CCTV surveillance cameras as they tick up in capability and definition. So lots of applications for 60 gig. In terms of Cambium network solution, it's CNWave 60 gig, and we're rapidly approaching broad commercial launch. So just a bit of a sneak peek here. We'll introduce 3 devices on our 60 gig platform. The V5000 distribution node, which you see here, which is a multi-sector solution that's capable of supporting up to 30 subscriber nodes and up to 15 gigabits of capacity. And then 2 client nodes, the V3000 optimized for longer range point-to-point connections, and the V1000, which is really optimized for address-specific deployments or connectivity to cameras and Wi-Fi APs, so more of a volume client node solution, all of which is Terragraph certified, Terragraph being the Facebook-developed meshing and air interface solution for 60 gig, and is being widely adopted within the industry. And architecturally, the ability for any of these devices to operate in a point-to-multipoint, point-to-point, or mesh configuration. So great agility in the application architecture itself. We'll complement the hardware solution with comprehensive network planning tools, which are very important in the mmWave space to ensure reliability and the criticality of line of sight. And with the balance of our product portfolio, the use of Maestro for integrated management and hosted controller functionality. So with that being said, we're going to introduce our last poll before we have our stretch run to the end of the presentation. And this one is focused specifically on 60 gig. And what we're interested in is your perspective on the practical use cases for 60 gigahertz. So I put forward some thoughts and some suggestions, but we're interested in those of you that are at the face of the fire of the market where you see application opportunities for 60 gig. So the poll should be posted, and if you could take a few minutes to react to it, I would very much appreciate it. While we're waiting for those responses to come in, be thinking about any questions that you might have that you'd like to pose at the end of the presentation or via the question window here on the application. And as with the prior poll, I'll post the results so that you as the audience can see what the group is thinking. All right, I'm going to go ahead and close that, post the results, and then we'll go ahead and move forward here. All right. So, as I mentioned, Cambium Networks has a wireless fabric. We have a very comprehensive portfolio of fixed wireless networking options that bridge licensed and unlicensed spectrum, point-to-point and point-to-multipoint, that use a variety of different standards as well as proprietary implementations that are optimized for different use cases and applications. This fabric exists because we believe, in fact, we know that no one solution satisfies all applications, all use cases. But we also recognize that many operators and customers will utilize multiple solutions to address their opportunities and address their challenges. And they want to manage those technologies, those solutions in a comprehensive management plane. And we do that through CN Maestro, that single pane of glass that allows network operators to manage this breadth of technologies, this breadth of spectrum, this breadth of standards and proprietary implementations in a very complete fabric through CN Maestro. And then we provide post-sale support and enablement through call centers and engineering resources in the field to help design, build, deploy, support those networks. So if you're not familiar with Cambium Networks and you're not familiar with that fabric, I'd encourage you to spend a bit of time on our website and our future presentations. In conclusion, before we move to the Q&A, what I hopefully shared with you today is a glimpse in the renaissance that's taking place in fixed wireless access and some of the critical vectors that are contributing to that renaissance. The fact that 3GPP, 5G really legitimizes fixed wireless access, and throughout the releases, the early releases, 15, 16, and 17, include some pretty critical elements that support the adoption and deployment and utilization of fixed access across both licensed and unlicensed bands and stretching up into 60 gigahertz. And from a Cambium standpoint, we're adopting those standards. We're initially addressing 5G with our 28 gig solution. We have a 60 gig solution that's forthcoming initially on 802.11ay, which is the standard that's available today. And we're able to leverage our decades of experience in fixed wireless access in combination with this broad industry investment in the 5G standard to really bring forward a compelling network solution for you. As I mentioned on the front end, we do have a series of sessions scheduled, approximately one per month, that come under the heading of thought leadership with some critical topics that we think are important to study. 6 gigahertz, we talked a little bit on the front end of this presentation, and we're going to share where the industry is at from a regulatory standpoint, what's going on a worldwide basis, and how we see that 6 gigahertz spectrum being utilized both indoor and outdoor. I mentioned that multi-user MIMO is really important to the fixed space, initially deployed in 5 gigahertz, but its utilization in the higher RF bands is really important, and how that drives to spectral efficiency and operation in high noise environments. We think that there's a grand experiment taking place with SAS and CBRS that's going to extend on a worldwide basis, and certainly we see it being utilized in a form or fashion with 6 gigahertz in the US. So what's our experience been there, and how do we see that progressing? And we're seeing the densification of of fixed wireless access through micropop architectures, and we've got products coming to market here very soon to support that densification and that micropop architecture. So we'll spend some time working through the whys and wherefores of that architecture and how those network designs will further extrapolate fixed access into suburban and urban environments. So there's a whole lot more webinars and topics that are available. I'd encourage you to hit our website under cambiumnetworks.com/webinars, and you can see what's available for the ongoing education and take advantage of it. So that brings us to the conclusion of the presentation. We have a bit of time here, and we can certainly take any questions over the next few minutes that the audience might have. I didn't see any come in written, but feel free to shout out or post them to the site if you care to. If not, I very much thank you for your participation and appreciate your attention.
Hi, Scott. There are a few questions that have come in so far. So this first one asks, will Maestro be capable of managing CNWave?
Yes. In fact, Maestro is critical, either as a cloud-hosted application or an on-prem implementation to support the larger networks of CNWave and specifically the meshing controller capabilities. So short answer is yes. The longer answer is it's a really critical component of the CNWave architecture and deployment.
There is also a question asking if there will be link planner updates for CNWave devices to be integrated.
That is also underway. So we have two tools that will be used to support CNWave network design, Advanced Network Planner, ANP, in conjunction with LiDAR data, will assist with network design. And then Link Planner will also be updated to produce network design support, bill of material, performance targets, etc. So again, short answer, yes. And the longer answer is not only Link Planner, but also the ANP, Advanced Network Planner tool will be forthcoming.
Are there 80 gigahertz devices in the roadmap?
Any gigahertz devices?
Yes, 80 gigahertz.
We do have an E-band solution in our PTP 820 portfolio. Sorry, I guess 820 and 850. So there's a PTP 820E and a PTP 850E that's supporting E-band today. And believe it or not, we're looking at higher RF bands beyond that for point-to-point configurations. You can find information on the 820E and the 850E. 850E being a pretty impressive platform on our website.
And that's all I see for questions right now.
Okay, well, that brings us really right to the top of the hour, so perfect timing. And again, I very much thank everybody for participating. I appreciate your attention and interest in the topics. And I believe Olivia will be posting the presentation and the recording for you to take advantage of downstream. You guys all have a great day, great evening, great afternoon, and look forward to talking to you at the next session.